Okay. Hi guys. Good morning, all. So it's nice to have you all here on this call. Um, yeah. So my name is Pavan, and and I'm working for an MNC, and my and I have over 20 plus years of experience working in different areas, from starting from solution architect to uh, what is this? I'm having trouble with this. 20 plus years of experience in data engineering. I have over 10 years, mostly around design development and building data engineering pipelines. I started this journey in Hadoop, and then we then moved towards uh, cloud native, like which are basically open source technologies. And then I worked even in as a data scientist for around 3 years. And then of late, I like until a year ago, I have around 3 years with ML ops, build again using the open source. And then I moved towards Google Cloud. So basically, I am Google Cloud certified, and mostly my role is around data engineering, ML ops, and little on the data science. So this is more about me. Um, so yeah, thank you so much. Yeah, and may I know, like, what is the just a minute of understanding who the audience are, so that it helps me to basically tune myself, like what you are and how, what your experience is and what you are currently doing. Is it okay for you guys?
Yeah, sure.
Yeah,
This
that
Yeah,
is
is
one
fine
sure.
to
to
start
start.
with.
Thank you so much. Yeah, why not start with one person, like whoever it
Okay.
is. Mhm,
So this is Mazhar from I'm based in Sydney. Currently, I'm working as a non-technical business analyst in technology side of the business.
mhm,
So I've been working as a BA from last 5 years.
mhm.
Yep. So keen to learn. We have an opportunity in our organization in GCP data engineering. So that's the reason I have joined the section. And also I've studied my masters in IT, but I never worked in tech, not in the tech side of it. So yeah.
Fine. Okay. Thank you. Next.
Yeah, hi, this is Sandeepan Ghosh. I'm currently working in an MNC. I'm having 12 plus years of experience. I'm currently based out of UK, and I'm basically working currently as a project manager as well as a scrum master. And but my technology background is PLSQL. But last 2.5 years, basically, I'm been into a non-technical role, and currently our account is going through Google Cloud migration. So, and that is why mainly I'm looking for this GCP knowledge.
Okay. So what type of migration, if I might ask you? Like, is it
Yeah, so basically, first there are a couple of steps. So first basic steps is the on-premises applications are going into the
mm,
migrating to Google Cloud. That
mm,
is one. Then there'll be
mm,
a database migration later on BigQuery. These things will be required.
mm,
So
mm, mm.
first one is infrastructure migration.
Okay. Okay. Fine. Thank you. Next.
Yeah. Hi, this is Arvind, and I'm a lead IT recruiter. I'm working in Bangalore. Based on it's a US based company. So I just wanted to change my tech. I mean, I just wanted to move to IT field. So recently, one of my friend got job as a GCP DevOps engineer. So I just wanted to do the same for me. So I just joined this.
Okay. Okay.
Hi, this is
Thank you.
Sudeep. I have like total, sorry.
Yes, please carry.
Okay. Hi, this is Sudhir. I have total 7 years of experience in IT domain, and coming to my means like why I'm came here means like current means like we also migrating few automation codes to GCP Composer. So I need to know about that. That's why I came. My background is like robotics and clicking domain. Totally, it is like a database domain.
Okay, okay, okay. Thank you. Next.
Uh, Hi, I'm Srinivas Rao. I'm currently working as a US-based company in Chennai. So initially, I was worked on some IBM FileNet, that is the storage area. So we are currently we are moving to migration. We have started the migration project, moving all the storage from FileNet to GCP. So that's why I was joined this session.
Okay, okay. So probably I think if I understand properly, most of your applications would have been a monolithic applications, right? IBM when you say, or is it
Yes, correct. Yeah,
CBM?
right, the
And you,
monolith, the legacy system,
yeah,
so old
legacy
system.
system. Yeah, yeah. Okay, okay. Yeah. Next, anybody?
Hi, this is Varaprasad.
Mm-hmm.
Yeah, presently I'm working as a DevOps engineer, Azure DevOps engineer. Presently, I have worked with the Azure as well as that is a AWS, but I don't have a knowledge on GCP. That's why I joined this course.
Okay.
Is it,
Mm-hmm.
yeah,
Mm-hmm.
how extent you have covered in this course, and can you give me brief description about this course and all this?
Yeah, we are going to go around understanding what this is on in during this session. So you will have an overview of what this covers.
Okay, sure. Thank you.
Mm-hmm. Okay. Anybody else? Are we done or okay? Okay, so we are done with it. So let's move on. So yeah, so basically we start with like, okay, what is it about data engineering? What you think about data engineering? What we all think about data engineering? Different categories of data engineering, like how we can um, do the how we can extract, transform, and load data in different ways, different designs, different architectures, and what is the advantages and disadvantages of each of these, and why we have to move to a cloud. And obviously here, since this session is more around Google Cloud, our emphasis will be more on Google Cloud rather than any other clouds. So basically, how do we migrate to Google Cloud, and what difficulties we had in the in doing data engineering before moving to Google Cloud. So yeah, so that is most about it. And then after that, we discuss about the services. Some of the services, I don't know, we maybe if we are bound with the time, so there are lots of services within Google Cloud, and maybe in subsequent sessions we will cover most more rest of them, but for now whatever we can squeeze, we will squeeze it during this session. And if I understand, this session is for 1 hour, I guess, if I understand. So we will see what we can do in this during this time. So guys, so some, I understand that some of us are already doing some part of data engineering. One of the persons mentioned that he is working on PL SQL, and some of them are already on working on another cloud. Some are moving on the are in the journey of migration to Google Cloud. So my first question is, guys, to you is, because we are on this session of data engineering, what do you, according to you, is data engineering all about? Yeah, anybody? Hello. Is my voice audible, by the way? Hello.
Yes, you are. Yes, you
Yeah,
are.
I am. Yeah, okay, okay. Yeah. So yeah, so just wanted to ask, or is it like yeah, any blank answer, like what according to you,
Mm,
what do we mean by data engineering exactly? Because we are now we will be moving directly into Google, cloud of the data engineering. So before that, we should know what exactly is data engineering all about.
Getting the raw data into making the raw data into a meaningful data.
Yeah, yeah. So that's one thing. Yeah. So basically, it is nothing but it's a discipline. It's kind of a engineering where we bring the raw data, extract it from various sources. It could be table in tabular form. It could be non-tabular form, and it could be coming from different sources, different domains, transforming this data and loading into some kind of a storage, where this storage can be utilized for producing some actionable insights. So basically you would maybe use it for some drawing some conclusions, using some dashboards, maybe using some kind of a visualizations tools, or use this data to produce some machine learning algorithms to create some smart applications. So that is about the data engineering is all about. When we talk about the conventional data engineering, I mean before 2013 or maybe before that, most of the data engineering workloads were revolving around three concepts called as extract, transform, load. So wherein you these are the three concepts, because when extraction is about extracting, transformation is about the transforming the data, and loading is loading into some kind of a data warehouse. But later on, things have improved, and we had to come up with more services added to this, because uh, more of active players becoming are coming into the market, into the system, wherein you want like to know like, well, beyond what is it that beyond this we want to bring into your system. And when we are all talking about data, it is very important to understand two three things. One is where is this data staying, and where is it going? So if data is the where, what are the boundaries of this data? Is it within our boundary, within the premises, or is it going beyond? So that means that it so they it means that we also have to come up with a design wherein it has to be secure. So so coming to this architecture here, it is now starts with not just about extract, transform, load, as you see in this one, in this particular picture that I am showing you. It starts with extract, transform, load, but it also goes on to analyze. So what once you load it, you are basically going to analyze, and then you are going to visualize. So basically to look into the tools and make sense of this data. Are there any deviations in the data? Are there any outliers? Is there any um, can we should the data be imputed? What is it that we more again we need to do? Is it normally distributed? So generally when we are talking about the data we expect it to be normally distributed, should not be skewed data, should not be biased data. So basically we want to make sure that all that is being addressed. And one of the tools that help us is the visualization tools. There are many tools like that in the market which help us to do this activity. And then once that is done, we will obviously would want to take it one step ahead. We want to have this models, some kind of a models which is basically kind of an equations, mathematical equations, which will basically provide us with uh, with some kind of a prediction, like what kind of results we might forecast in the future. So based on the historical data, so based on the data that it is producing, and whatever the data that the company has within its domain, what is it that what can we provide as an meaningful insight from this data? An example is maybe something like, okay, which of the products in a particular store will have value? So or maybe if certain product would be kept in a certain location, what is it, what kind of value will it add, what type of customers will buy what kind of products. So these are the kind of questions maybe we using the so we that will using the historical data is what we can do with the model training uh, model with using by creating or building the models. Once you have the models, the next thing obviously is you would want to operationalize these models. And when you mean operationalization, you would like to take this in the deploy it onto a kind of a production environment. As you see in number of cases, we see that out of 8 models that we build, 10 models that we build, 8 will are just going nowhere because they are not, we don't have a system in place that can take them to production. So obviously this is becoming critical nowadays to how do we create the models and how do we operationalize these models. And then once we have this in the production, obviously we would like to monitor these models like the, so you, it is not like you create a model and it works lifelong. It is not that case. So there are two major concepts here. One is called as a model drift, and another one is the data drift, and another one is a concept shift. So that means that over a period of time anything can happen. Your concept might change, your underlying business rules might change, because of which the data that is coming into the system will have an impact, and because of that your model might suck. And second thing is the data might shift. The data that it is generating over time might be different. That purchase, let's say for example, the customer who is buying a particular product now, which is very famous, let's say, and over a period of time the product might so the capability might diminish, so it might come down. They might go with a different product and may not even choose that product. And what would happen, that means that it will have an impact on the data that you are that model is being created upon. And then similarly the model also will decay over time, because you might require more amount of data that you are providing to the model. The model might not require some of those features, which we call it as features. Those features are not required for the model, and then that model might decay over time. So overall there are these three concepts that we have to take care of. And then once that is done, it will go into the monitoring stage. And all this, how are we going to do? We are going to put up some monitoring tools. We have to invest our time in creating, building, and testing, validating, and deploying these monitoring tools, so that they produce provide all these details, like whatever I said, like the concept shift, the model shift, and the data shift. So then comes so once we know that, well, there is a, this is not working, this border data has drifted, then what we are going to do, again we pull the more data, so we extract more data, and the cycle continues, and again it goes to the transform, load, and analyze and visualize. And w- and then everything should be in a secured manner, because we are talking about data here and we do not want to compromise on it. So it should be within the boundaries. You should not be able to share this data. There should be levers and controls at every place. There should be access controls, people, and we should be giving data to the right person. The person who requires it should only have that active data needs to be morphed, and should not be shared. So all that levers and controls should be always be there. So the security plays a important role in all of this. And why are we talking all these things? Because we moved from extract, transform, load earlier to all these now. The reason is that data engineering as an industry is moving towards more of going beyond our conventional capabilities of extract, transform, load. It is going towards it is so a typical data engineer might have to dive and into this, what kind of model it is and why is it producing such results. I will tell you one case where I was working with one of these data scientists, and he was complaining on and off that my model is not providing so good results. And but then from the data engineering person, we feel that, well, the data that we are providing to the data scientist is accurate and appropriate. But well, there is always this friction, and then the data scientist again comes back to the data engineer, and he says, well, this is the case, then what is the, as a data engineering, we have to do? We need to get put his cap and understand what he is doing, and how is he training, how is he building, and what is he trying to do, and all other things. So that means that there is a necessity that as a data engineer we'll have to understand what models they are building, and how this model is behaving, and how we are going to operationalize. Because when you are going to operationalize, obviously then you cannot say that this is a DevOps person guy who can do it. No, because again he will also depend on data engineering. So but then the data engineering cannot work in silos, so he needs to collaborate with the DevOps engineer now, and try to understand what data is the has the model produced, and why, and what are the type of mm, met how did he deploy this, and what is the monitoring is all about. Like when you talk about monitoring, we are referring to metrics here. So what is the model metrics looking like over time windows, over slicing windows. So different windows, how is the model showing up on the screen. And if it is not, then obviously the first question is they will not doubt on the source data. They will doubt on what kind of transformations and data science work that have we done. So when we do the reverse engineering, it will be most probably boiled down to the data engineer again. So that means that the data engineer again will be pulled into the situation, and then asked about what kind of transformations and load capacities he has done. So that means that overall, in all these situations, whether it is in data engineering, hardcore data engineering, where extract, transform, load is concerned, or whether it is a work of a Power BI kind of like a visualization tool, or it is work of a data scientist, or is it if it is a work of a DevOps engineer, um, or it is a part of work of our security personnel, like whoever is taking care of admin part of it. Everywhere data engineering is important. So so obviously the first question is, whenever there is a regulatory or a concern or a security concern, the first thing that would be asked is, why is it that the data is being shared? What did you check this? Did you consider the PII, personal identification data? Where did you put this check? How did you make sure that the data is not going beyond the boundaries? What are the algorithms? Show me the algorithms that you have written, where it is basically redacting the potential data, so which should not be shared. So basically all these things, and where are we putting the levers that certain person should be given only certain access, and should not be given more or less. So which is, we call it as least privileges. So basically it is all this is the discipline now of what the data engineering is all about, and how we can do all these activities, apart from again talking about how much scale, at what scale are we doing this, how reliable is our pipeline, what is our fault tolerance mechanism, and what is our risk, like if at all, if it happens, what is it, our risk mitigation. So so basically it all revolves around all of these topics, and that is what is the next generation of our data engineering talks about. And um, and that is what we are going to learn. So, and that is what Google Cloud also insists basically. So is this clear, guys? Any questions? Okay, then goes to the next thing, which is the types of data engineering. So basically, data engineering can be categorized into two types. One is the on-premise, and another one is the cloud environment. And on-premise basically is something data engineering work. we're basically using our own tools, proprietary tools, and it is basically shielded from any kind of um, what you say, intrusion. So that is the main purpose of an on-premise. So what is the characteristics of this on-premise workload look like? Basically, the characteristics of this on-premise is that your compute, the storage, and the network, they are all defined. So it is within the boundaries. So we cannot scale up, scale down, and everything adds up to the cost. We have to understand that, okay, it all depends on the amount of data, amount of compute that um, we as a company would want this. So the more the data, obviously, and the more the transformation, the more the compute and the storage is required, and obviously the network capability is also required. You can this because the current network bandwidth may not be sufficient for the amount of data and the compute that we have. So basically, this is all defined. And the third one is, obviously, if there could be a downtime, we would have there should be a maintenance window whenever there is a production deployment, or maybe you want to scale up or scale down your some of your infrastructure, do some upgrade your software tools. Then obviously, that you need a maintenance window wherein you have to bring down your production systems. Similarly, if you are using any open source softwares, then that's another case where you would want to handle this, because there will be licenses. You need to understand that we will have to deal with the license management, with those some open sources, create a newer version of it, buy it. So that means that there is some procurement management, a lot of management overhead in an on-premise. So starting from procurement management to license management to the admin management, some administrator, some kind of an administrator, maybe it could be a DB admin or a network admin or software admin, whoever it is, they need to get into the understanding what this software is all about, and what is the lifespan, and what is how do we install, when do we install, what kind of repercussions it might have on the production when we are installing it on a production, to properly test it on development. So whenever there is a version change or anything you of open source or anything that you bring off the shelf, then obviously the first thing is you would want to know whether this is working or not. So if because this will have an adverse effect on our production environment. So that means that there is a lot of overhead on top of it, and there is expects downtime. So the one which we are talking about here is involves full-time availability of database admins. Yes, because if it goes down, we need to be available. If there should be network admins, L1, L2 support always available on the toes 24 by 7, to know whenever there's a certain system breaks, immediately somebody needs to come and fix. Then it is secured. Yes, one in a way it is secured, because it is within the boundaries. We are not sharing the data, or the data is not going beyond the company boundaries. So there are levers and checks put in every place. That's one thing about it. And then the third one is obviously the frequent maintenance overhead, and that's what I already mentioned. So we want there should be maintenance at every layer, from software to compute to storage to network to licensing, managerial overhead, everything. There is a maintenance, there is overhead everywhere. And there is an end of life that we have to consider. So if it cannot go on and on, there will be wear and tear to you over a period of time. You need to keep an watch on how your systems are all working, and at what is the right time to do an end of life. What is your strategy to go for an end of life and move to a newer system? So that is all we have for an on-premise data engineering. So basically, what we see is more than the positives. We have lot of overheads that we have as a company that we have to deal with. And we are not even talking here about the scalable option. So what if how do we address the scalability, how do we address the fault tolerance, how do we have addressed the high availability of our resources kind of thing. So they are again another aspect of it. So so that these are the characteristics of an on-premise. So because realizing these issues and other things, then we have started to migrate towards the cloud. And in the cloud, basically we have three different clouds as which we talk about in the market. One is the AWS, and second one is Azure, and third is the Google Cloud. And main purpose of going to Google cloud environment is basically to scale up your resources, scale up your resources, provide high availability, fault tolerant, in secured and secured manner. And and you worry about only your business and not about your infrastructure and many more. So that means that you offload most of your infrastructure apart to the cloud, and and we focus only on the business problems. So that's where we would want to go to a cloud. And even in the cloud environment, there are we can categorize into two different options. One is cloud agnostic, and another one is cloud specific. And so what exactly is about this cloud agnostic all about? And when we talk about this cloud agnostic, it's basically talking about how what are the tools, open source tools and proprietary tools in the market that you can bring and join them together to bring build your product. So that is one idea of a cloud agnostic part of it. So here in this picture, if you look at it, we are having 4 or 5 different applications which are interacting with the different domains. One is containerd, runtime, cryo, and docker, different services, which these services again interact with another set of services, proprietary services like Kubernetes. And then there is Azure, and then Google, VMware, Amazon EKS, and orchestration management, which again interact with another set of resources, and another set of resources which are Terraform infrastructure. And on the right, you have these observability tools which will basically monitor the how your application is performing. And there are different tools in the market like Prometheus, Grafana, and yeah, fluentd and elasticsearch. So these are the tools that are there. You can bring and join it into this together to make it make this work on a cloud environment. So they basically are designed for this for cloud. So you can and leverage the cloud environment. So they are different, these are different players who are there, and we can just bring them and then join them. One advantage, there is a positive positive part of it, and there is a negative aspect of the you going this route. The positive part is that for the company, you can now bargain, do a better cost management. You can just go and do a bargain. Okay, these are the services that you have, okay, which you require for your building your data pipeline. Okay, this is the cost you have by going this route. Maybe this is a cost effective way. And another point which the company looks is, well, if we are going to if we are going to use a cloud specific service, then we might be locked with that cloud. Then what if tomorrow, let's say in down the line in 6 months, yeah, I want to change my cloud. I'm not interested because I don't have a proper feedback mechanism or a proper support with this cloud service provider. Then what is the option I have? If that is another question that the clients will look at and to answer, and there is no proper answer for it, right? So if we are using only all the services from one cloud provider, and later on you realize that as a company, no, we this is not going anywhere, and we would want to we are not able to do anything, then it is going to be a disaster. So so they will cleverly manage this, saying that okay, we'll these kind of companies, the companies who think that, well, our IP is more important and we do not want it to be cloud locked. Such companies strategy would mostly would be like, okay, go with cloud, these kind of tools, bring them together and join. But however, this has an overhead on the flip side. That is, you now have to manage all those tools. You as a person have to manage like what, when the Grafana version will change, and support the required for Grafana. There is no, and it's because of so many tools and out in the market, the competency is becoming, will become an issue. You will not have enough manpower, enough resources who are equipped and have knowledge about all, enough knowledge about all these diversified tools. So that on the flip side, this is what will happen to the companies. So basically they have to balance themselves whether to go with these tools, or whether they have to go um, with all the cloud specific to cloud specific option. So so you will find companies wherein, so if you might have gone realized already in your company that if you correlate what I am talking to what you is happening in your company, you can just think it to yourself, and you will find cases wherein it is using what I am explaining right now. And another option will be using some of these tools with the cloud specific tools, and another one would be only cloud specific tools. So there will be three different options depending upon the business drive. So what they are thinking, the business and the people are thinking, and what drives them to move to cloud, it all is dependent on what is the motivation to come into cloud. So that is the flip or side of using this cloud agnostic tools when we are talking about it. And then comes the cloud specific tools, and here it's very straightforward. So that means that tools provided by the cloud service provider, no other tool. Now one of the, and here again we have we don't have to rely on managing those cloud native, operationalizing version management, and deployment of those tools, building up the deployment pipeline, your the Terraform pipelines and other pipelines, all this worrying part which you used to do earlier in using the cloud agnostic. Oh, will you not have to worry too much about here in this case, because it is all taken care by inbuilt by the tools, or if it is not there, with the minimum effort you can go, you can operationalize your environment. So that is what this environment provides. And the management overhead is very less, zero to less or minimum or no issue at all, because everything is taken care. So here in this case, again we have three different options in the cloud specific as well. One is no ops serverless option, wherein you do not have to spin up, take care of any infrastructure. You do not have to deal with the version managements. You do not have to deal with the downtime operationalizations and other things. And only what you worry is about creating your applications. To the more generic approach, that is you bring your own instance. We will provide, so the cloud says that we provide the infrastructure, and you bring your own proprietary softwares, and you can basically in launch and install and work on those particular softwares. So from on the left, all the way from the left to right, you have all sorts of different windows. So you have mix and match as well, like wherein you half of the services you can have it as no ops, fully managed, and another one is fully maybe full unmanaged, and wherein you would want to manage it, and and operations required. So you can have a mix of match, you can have all no ops no management as well. So when we talk about it here, since we are mostly work speaking about, we are our main say our session is more focused on the data engineering. I picked up this particular snippet which only shows the tools and services for us for the data, from the data engineering standpoint only. And if you look at it, it is showing that, well, what are the different tools, the predominant tools. Not, these are not the only tools. When you look at it, there are more tools than this, but here we are looking at the core tools, basically I should say, the core tools that we are used within the cloud environment. And obviously this is same kind for the other clouds as well. Like you in AWS, you have corresponding tools for them, and you have tools similar. You have one-to-one mapping of these tools for Azure as well. So you go back and sit on the drawing room and you check what are the tools they are corresponding to. You will find there will be a corresponding tool in the other environments as well. So so coming to this capture, basically this is basically extraction. There are tools. So when we talk about extraction, there are tools like PubSub. There is data transfer service, storage transfer service, and cloud IoT core. I'm not going to get deeper into this because we will go deeper in the subsequent slides. But the only thing what I want to emphasize now is just to, okay, here are the tools and how we can bucketize these tools. That is the only motivation here now. So yeah, so I think I'm going faster. Do you have any questions, guys? I'm just talking on. I don't know whether it's uh, it's meaningful, and how do you find this? Am I fast or running slow, or what do you think? Anybody? Who is this?
Yeah, okay, no issue.
Majar. I have people like Majar, Sandeep, Arvind. Any questions? Arvind, Sudhir, Varaprasad.
Yeah, it is
Are
okay
you
for
going
me.
to cover from
Yeah,
basics? Yeah. Are you
continue.
going to cover from
Continue.
basics?
I'm
Yeah,
good.
this is, yeah, yeah. Thank you. Thank you. I think there is one question here I see. Are you going to cover from basics? Yeah, we are talking the basics now here. We are referring to the basics. So basics, do you have anything on your mind when you, who is this who put up a chat on this? Somebody is asking me the question on this. I am not able to open this. Okay, Varaprasad. Visual path. Okay, okay for me. Okay, okay. So fine, that's good. Okay. DevOps. So what about DevOps? DevOps is not the part of data engineering, as I said. It is a different topic. But as I mentioned earlier, as a data engineer, you still have to get into the DevOps part. It is not. So the thing is, actually, we're not directly dealing with the DevOps. We will be definitely dealing in case of MLOps. Now you might be wondering, like, what exactly is difference between this DevOps and MLOps? DevOps, where we talk about DevOps, we mostly are referring to CI/CD, continuous integration and continuous deployment. But for the MLOps, we are talking about continuous integration, development, and continuous training. So there is a feedback loop also uh, we have to deal with, and that continuous training is where a data engineer plays a vital role, because how the metrics has to be established, what kind of metrics we need to build to check for deviation, drifts in data, drifts in models. So who is going to provide that? Because it is only the data engine, because he is the front end who got the data and extracted, transformed, and load. So he knows how the data is behaving. So what kind of levers and checks have to be put on the data to understand whether the data is drifting or not? Only the data engineer can provide. And with the help of the data engineer and the DevOps team, they will put up these dashboards to check, well, to put up this MLOps pipeline in place. So we are not for DevOps. Definitely, there is not much in DevOps that we can contribute as a data engineer. But MLOps, yes, for sure there is a need of a data engineer in that place. Yeah. So, fine, guys. So any other questions?
Hi Pawan, Nagaraj here. Good morning.
Mhm. Yes,
Uh,
Nagaraj.
are you going to cover any real-time projects in these sessions?
No real-time projects. I will be mostly focusing on the tools and how we can use them, and because it is all bound by the amount of time and the schedule, so and determined by the capable schedule. Because so we need to understand how this all works out. So for now, I cannot promise.
No, after the finishing of all these courses, I mean all these topics, are you going to give any, I mean, a real-time project that already have
Yeah,
done?
yeah, I can provide you with the real-time project of that, but I will may not be involved in that because I'll have so
So
I
you are
can
going to
support.
provide the documentation, right? Documentation and the code and the
Code and
process.
documentation, no, we will take a use case. I can provide, we can take up a use case and start you working on the use case, because now in the beginning we will be learning on the services, individual services. The use case will be more about how we join those services and create that particular real-time project.
Okay, got it. Thanks.
So what services will be covered in data engineering? Yeah, there's so you what you see some these will be little of these will be covered. Let's say for example, so now as I we will go through that in the next slide. We are going to go through that what services will be covered in data engineering, and what will be emphasized and what we are not going. So there are different levels. One is we may not cover, we will cover only theoretical. Some we might cover little bit of practical, and some of them is out of bounds even. So basically some of them is like networking is there, networking of it is. So we can only talk theoretical about it. I will not be able to show you how to create a VPN, how to show you create a public network, create a subnets and other things. So some theoretical knowledge will be required, and in such situations, some situations where we definitely have to know about a little bit of practical, may not be in depth, so that to understand what that service means. And just there are some of these which are core technologies, there we need to go and get deeper and understand the practicality how by doing some exercise like building up some dashboards in case of your Looker Studio, or maybe in BigQuery building writing some queries and understanding what does queries mean, how the tables are constructed and other things. So basically some of these places where we have to emphasize, some of them we change. So it depends, it varies from one side to another. It basically oscillates, depends on the kind of service that we are working on. So like say standard storage transfer service, we are not going to work on storage transfer service because we don't deal with, because first to explain a storage transfer service, there may be a situation of an on-prem and other things, different cloud, other things have to be explained. So we'll have to understand that we have to theoretically understand what the storage transfer service is, and data is there in a bucket, and then we need to talk from that point onwards. Similarly, IoT core. For an IoT core, again, there is a, it is basically talks about a streaming platform. You have this streaming, some kind of a live stream data coming from different devices, IoT devices. And cloud IoT core is a system that provides you with all these things. So, but then, yeah, that is something which we have to mimic only, but we cannot know, get into the details. So that is what we have. So when we, so anything else you have, do you teach us any tools? Yeah, we are going to deal with the tools anyways. Okay guys, did I answer those questions, all the questions? Yep. Can you also share the course content with us? Yeah, we are working on it, I mean, with the team. So we will let you know about the course content later once we have our discussion. We are working on it. Yeah. Thank. Okay. Okay. So if we are done, let's go back to this topic again, back to this screen. So we first capture, then the obviously is the which is we call it as extraction. The process is called as a transformation, and then store is called as a loading of the data. And then we analyze, and
The
then we
screen is
use
not
this data.
visible, right?
Oh, not visible. Sorry, 1 minute. How is it now? Are you able to see?
Yes.
Yes.
Okay, fine. Thank you. So yes, so first thing is about the capture, where we basically it means, in other words, it is nothing but extraction, or also called as a ingestion, a data ingestion, where you get data from varied sources. And here if you look at it, there are different types of sources and different ways of bringing this data into your domain. First one is about the cloud pub sub, and the pub sub is basically is a service where you is required to bring in live stream data, a synchronous or asynchronous kind of a data of data. So mostly used for streaming data. So any of the IoT sending any data, the first go to place is the pub sub, and from there it will send it to the processing unit. Second one is the data transfer service, data transformation transfer service, which is basically like, okay, some kind of a uh, transfer service wherein we basically bring the data from on premise to the cloud. So there are different types of services. Here again we have gs util, the command line tool which we have. Then there is a transfer appliance, that means you ship a device to the particular location, take the data and place it in your data center. And the third one which you see down below is the storage transfer service, which is again another one which will be basically used, predominantly used for bringing data from other clouds. Basically it can be used for on-prems, but also mostly used for bringing data from other cloud to the Google Cloud environment. That is the what is storage transfer. Cloud IoT core is basically a service wherein it is used as an interface between the field devices. Field, when we talk about field devices, it is like a mobile device. It could be some kind of a gadget or an equipment that is emitting data, which we want it in live, which we want this data to do some kind of a stream. We want to build some data pipeline out of it. So what is the issue here? The point is that that there could be millions of devices, and our environment should be able to cater to those data produced by these devices. So the main bottleneck is the number of devices that are in the market, millions of devices emitting data. Each is emitting data, but at what frequency? If you are saying like 800 frequency, that means that at 800 data points per second. So which means that so many data points are being generated in a second, which will be have to be which has to be captured by this system by one device over a period in 1 second. And if we talk about 24 hours, that means that we are like what we talk, it is it's the astronomical data that we are talking about here. And you take that data, and our system should be in a position capable have capability to capture this data, process it, and store it within the systems. So there are different services within the cloud, and one of them is the cloud IoT core. And another one is a cloud pops up, which would basically these two services main job is to cater to the streaming data part of it. Then comes the processing part of it, which is basically there are three services here in the processing section. These are the core services. One is the first one is the data flow, which basically it's the no ops. Again, as I said, there are categorized. Our services can all these services can be categorized into three sections. One is the no ops, fully managed, and second one is the uh, like a middle place wherein you can bring in your own services, a part of it, and you would want to manage. And the third one is you manage everything. The end users will manage everything, and the Google doesn't do anything, just provides the infrastructure. So this one comes in the first one where it is no ops, no management required. Everything is taken care by the pipeline. With what we have to do as data engineers is to write the code, and it provides us with the tool called as Apache Beam, and we use write the code to create pipelines using this Apache Beam to in data flow. So we don't manage the clusters, we don't spin up the clusters, everything is automatically taken care. And this tool also has a flexibility of understanding well what should happen in the case of a real-time streaming. So it can be used for both real-time and batch processing, so it can cater to both our needs. So the same pipeline you build can extract data from some kind of a storage on one using one kind of a connector, and then using another connector it can basically get streaming data, basically from some kind of a IoT core pubs up kind of an environment. And it can grow or shrink according to the workload. So at times, say for example, there is a situation where there is more workload, there is more feeds coming in, then the amount of compute and storage will have to increase, so it will increase it to that extent. And once if it realizes that that amount of compute and storage is not required, it will shrink automatically, so without our involvement, basically without any managerial or administrative monitoring. The second one is the data prog. The data prog is again, it's basically we need to manage it. It is not a full no ops kind of a thing. But the point is here is that it is best suited for workloads that you have built earlier in an on-premise using Hadoop environment. So if you would have, if you are already working on in an on-premise setup, and you have been using Hadoop for quite some time, and have created some Spark jobs, and created those notebooks, and have Hive and other stuff, this is the go-to environment. So you bring those workloads onto the data prog, and when you open the data prog, you will realize that when you see the service, it is more or less the situation where you will are actually working on a kind of a same Spark notebook, utilizing the same kind of a clusters, and spin, and you will be able to write any Spark program as you would do on a Hadoop environment. It has capability of running ML algorithms. You can run ML algorithms. It has inbuilt GPUs. So if you want to run a deep tensor deep neural network and neural network algorithms, so we can connect it to a GPU clusters. So it has all those capabilities. It has you can basically spin up and spin down the clusters if not required. You can basically utilize a preemptive clusters if you for low configuration jobs, like for example some kind of a logs you are want to monitor, which are like not that important, so you can use those as an advantage to bring down your costs. So all that flexibility is provided by the data prop. Next is the data prep. Data prep is basically used to redact any data. So basically you want to prepare the data, and the first thing obviously you want to check is to see if there are outliers, there are any deviations in the data. Is there any customer proprietary data? Are there any SSN numbers, if you're, any confidential information, phone numbers, salary details, or anything of that sort, any personal information. It will identify, it has an inbuilt intelligence. It will show that, well, this is the situation, would you want to remove this kind of a data? So, and then you can basically remove that, redact those information, and then prepare a pipeline. So you can create a pipeline that will connect to the data flow environment, and process the data with the information that you allowed it to continue, basically. So this prep is basically used for that purpose. It is basically a visualization tool, no coding is required here. And then after that, you have the storage. In the storage, you have two components. There are other components as well, we will discuss later. One is the most obvious ones are the storage, cloud storage, and another one is a BigQuery storage. Cloud storage is we can associate it to a kind of a data lake, and which is basically you can store here any kind of data, raw data, any kind of data, which is structured, unstructured, semi-structured data. You can bring your data, store videos, audios. You can store any CSVs. No limitations is required. Without any any strings attached, you can put any data here. The best use case of this used cloud storage is when you would want to bring your data from on premise. So the whenever you doing, some people have mentioned here that they are working on the migration project. Guys, for you, this it should be the first environment for to bring your data. So whenever there is a data on premise, that and data as it is would be first going towards the cloud storage. The raw data will be put into the cloud storage, and this is also called as a staging area. And from there, your actual processing starts. So your remaining processing tools like cloud data flow, data prep, data proc, you can connect them to the cloud storage, and then do the remaining processing job work, whatever you want to do on the cloud environment. So for the people, especially for during the migrations, you would want to bring these tools. You want to bring the tools from the you want to store this data in the storage. You want to query them. You don't want to move them because they are this the amount of data is too high. Then this is the place where you can store. There are again different concepts in storage, like how depends on the cost perspective, which we'll discuss later when we actually get into the details. Then after that, BigQuery is basically a petabyte scale data warehouse. So it can basically used for querying purpose. It is an OLAP database, and you basically used for analysis. You can it can do some analytics on it. It has recently, like a year ago, they have come up with machine learning on BigQuery, so you can do machine learning on BigQuery. And recently, 3 months or 4 months back, I was into this Google Cloud Next, and they were talking about Spark as well. So you can basically run Spark jobs within BigQuery, so you don't have to move. What is the advantage? The advantage is you don't have to move the data anymore, and you do not have to understand about performance tuning anymore. You are just we can worry about how we would want to execute these queries and it will scale to the amount of compute and storage it requires. So basically it decides how much compute and scale is required. And for a terabyte of scale of data, if you would want to query any data, you will and we can go and witness it once we start this exercise, that it will run within a matter of seconds. Basically within a minute, it can query the data. And the more important thing is that it is a columnar fashion that makes it more robust and performant orient. So that is about the BigQuery. We will we will discuss it much more later on.
In storage, there are other options which are not shown in this picture, like Cloud SQL, which is for a transactional database, Spanner, which is basically a multi-regional, horizontally scalable relational database, and there is a big table, which is a NoSQL database for low latency, high throughput database. So basically, there are other databases as well which are not shown, but we will be looking at them again when we are actually going through this course. After that, we have analysis files. In this, we have data warehousing. Again, so you can use it for querying purpose, you can use it for machine learning, you can use it for visualization, all these things. From BigQuery, you have connectors to different other services in Google Cloud. There is one which is a cloud AI platform. There is Vertex AI, which they call, was like a couple of years that Google Cloud has brought, wherein it is a single umbrella, it's a single window for creating depth, that is building models, train, test, validate, monitor, and deployment of models. So it is a single window, single platform for doing all these activities. You can do canary deployments, you can do A/B testing, and all these things using this Vertex AI, which is not mentioned here. We'll see later on. And then apart from that, there is a TensorFlow, which is basically Google proprietary again, and Google provides us with TPUs, unlike GPUs that we know here conventionally when we train a neural network. So it comes up with the TPUs. It's much faster than your GPUs. And to leverage that, obviously, it provides us with a platform to run the such algorithms that require tensor processing units, TPUs. And then after that, Looker is, and Sheets, Google Sheets. You can integrate Google Sheets with BigQuery. Looker, which is a Visual Studio, similar, which is like a Tableau or a Power BI. It is similar to that. uh, so that is about the how we use these tools, how we can use do the usage, how we can use um, the data, and how we can build models. So this gives you an introduction about how, what are the different core services and how they are bucketized, and in what stage these services are used in Google Cloud. So that is about it. And down below you will find three services: data fusion, which is a processing unit, which is similar to data flow. Only difference is that there is no coding involved. It is all clicks. Using clicks you can create a data pipeline. So easy, no ops, so there is no operations involved, no servers in, no, we don't have to manage anything. And data catalog is basically to maintain lineage, and to maintain schemas, to understand where the data is located and what kind of data is required. So we basically create catalogs, and that's what data catalog is all about. Schema management is what that it does. Cloud Composer is similar to it's a workflow orchestration tool. It's similar to our Airflow. If anybody of you have worked on Airflow, it is you can schedule a data pipeline at some time. So if I want to schedule it at so and so time, and complete this pipeline, I can basically schedule this pipeline. And to that, again, it is a fully managed, no management required. So basically it is all taken care by the cloud. It's also called as Cloud Composer is also called as a managed no ops Apache Airflow on for Google Cloud. So that is all about this cloud specific services all about, guys. So we will be looking at them in depth, one by one, in later in this course. So that's about it. What is it? So what does this Google Cloud Data Engineering does? Basically, the Google, when we talk about the Google data engineering part of it, he does all of this. Unlike the conventional data engineering, he will have, so data engineer in Google Cloud will have to deal with designing, building, operationalizing, securing the data, monitoring the data processing pipeline, and also look into compliance issues as well at scale. So this is what our data engineering and data engineer in Google Cloud will be doing. And you read that last sentence, it is even interesting. Data engineering should also be able to leverage, deploy, and continuously train pre-existing machine learning models. So that means that data engineering from Google's cloud standpoint also requires knowledge of more a little bit knowledge of models. How do we train, deploy, and validate these models? Any questions, guys? I think somebody has opened the window. There is some thing. Okay. So fine. So now this is how it looks when we put it in the form of an architecture, like how where the each service will sit in the position. And this what you are seeing right now is a case where your the data is being streamed. Data is streamed, and this one is basically taking that data and processing it and utilizing it for and building some kind of a real-time application. And on the left, if you look at it, it starts with PubSub, and before PubSub you will have Cloud IoT, and before Cloud IoT you will have devices. So the devices will from devices your Cloud IoT will get your the data, and from PubSub will get data from IoT, and from the PubSub the streaming data, the data proc, which is the managed Hadoop environment, is basically utilizing that and basically it's transforming it and loading it. So you will notice that there is one going to the cloud storage. So it will basically store into the cloud storage. The BigQuery, which is an analytical tool in Google Cloud, query takes this data from cloud storage and then does analysis on this particular big data, and puts and creates aggregated tables, and then this aggregated table data sets will be utilized by our visualization tool. And the visualization tool in Google Cloud is Looker Studio. This Looker Studio is basically you will visualize this data and provide some the insights, actionable insights. Maybe it will help in creating the, it is also used to assist in creating the features. So what are the the features that can be that our model can create. So once you have these features and other things in place, your the Vertex AI tool will basically utilize those features and and create models, basically train, test, validate, and then we'll be able to deploy it. So under one umbrella, as I mentioned, Vertex AI, all these activities creating to deployment is taken care. And once you deploy those models, obviously you would want to monitor those, how they are all performing, the entire infrastructure, and also your models. So entire all these services, how they are all performing, and how the individual parts are performing. And how do we do that? In Google Cloud we can do it using Google Cloud Monitoring. And if there is any changes in this, you again go back to Dataprog for further transformations, and again going take it to the cloud storage, and this loop continues basically. So this is one kind of an architecture. You can have different use cases, but then just wanted to show like, okay, those are the services which we saw earlier. How do we fit into this one in a kind of one architecture? Like how do we look at it? So yeah, so this is mostly about the responsibilities. We architect, design, develop, leverage, deploy, and operationalize, that is CT machine learning algorithms. And also we have to ensure the quality of the data and the model output. So these are the main roles and responsibilities of a Google Cloud data engineering. So now we start with the data services, engineering services, and mostly around the compute, storage, database, how they are all positioned, data analytics, and the AI ML. In compute, we have these three services, which are compute engine, preemptive VMs, Kubernetes engine. We'll not be covering all these things because these are out of scope. Compute engine is something that we might cover, we will be covering little bit, but the remaining ones is comes under the different concept called as cloud architect and other things. So whatever we require, to whatever extent data engineering requires, is what we will be learning here in this course as part of this subject. Then comes the file store, storage, persistent disk, and a local SSD. Here we will be more focusing on the cloud storage because cloud storage will be used more frequently in this thing. Persistent disk and a local SSD file store will be learning theoretically mostly, and will not be having much use cases for this explaining these concepts, because when we talk about the cloud, um, we do not want to have your what is the main motivation of a cloud, and it says that you would want to have it in scale, fault tolerant manner. But if you have your data in a local SSD or a local machine disk, and once let's say for example you have spin up a cluster and you want to have data in a local SSD, then obviously one reason, on the positive side, it is fast because your data is stored locally. But on the flip side, if the worker node goes down, then the data along with it also goes down. That means that there is no fault tolerance. It becomes a single point of failure then. So situations like that, we don't focus much. You won't focus on the cloud storage. So that is about it. And then in databases, we'll be discussing about big table and spanner and SQL most of the time. We will be touching concepts of firestore, but definitely not memory store. So memory store is not, we don't have many use cases here. But firestore little, yes, because it is a document database, and big table little, but we don't have use cases because big table, the issue with big table is it is very expensive, it is very costly. Even if you are doing on Google Cloud, we should be very careful dealing with big table because it will eat out your money if you are don't if you forget to bring it down. So we have to be careful with this big table, and spanner similarly, because this is a horizontally scalable database. And we'll definitely look into SQL. So some things which the problem point is that, as I should say, we will be touching those concepts, but there are constraints, so there are strings attached to them in terms of cost, and we are bound with cost and other aspects of it, which will and we have to consider that when we are dealing with these services. BigQuery, yes, in data and analytics, BigQuery definitely yes. This is the core component in our data engineering space. BigQuery ML we will touch little, or not much, because as I said, for an data engineering, we should know how to deal with ML algorithms, but we should not be requiring to understand in depth what that algorithm is doing, why it did not perform, why, and understanding the nitty-gritties of an ML algorithm. We definitely need to know some concepts, and for us to help in explaining and understanding, and sit with the data scientist to figure out and resolve the issues. To that extent, we will be learning. And then the third thing is Cloud Composer is basically a managed Apache Airflow. We will be looking into it. Data flow, yes, we will look into it, which is basically a data processing engine, managed no ops. Dataprog, Hadoop workload, we will be looking into it. Fusion also will see little of theoretical. It is similar to the data flow Dataproc, where we build the data pipelines. The only difference is that here there is no code involved. We are not going to write any code. Very with simple clicks, we can build a data pipeline. Data prep is mostly around how do we prepare data. As I said, how do we redact and other things. PubSub is basically used for synchronous, asynchronous. Data Studio for visual, and Looker for visualization. So these two tools are for visualization. We will maybe look for into Looker or a Data Studio based on our availability, because both are visualization tools. We will not be able to cover both. Only one can be covered. AI ML. is mostly around Cloud Vision, AutoML, Vertex AI. We'll be definitely looking to Vertex AI and AutoML part of it here. So this brings up the suite of services in data engineering services, the more services that we will be looking into, and the services that it provides. Generally, the services that are available in Google Cloud. There are many other tons of other data engineering services like how do we use natural language processing, how do we use the speech to text, audio to text, and all those things. Lots of other services you can get into the documentation, but here too we'll confine ourselves to the more important and general and day-to-day usage of our services. And obviously, even in this, to my experience and to people who I talk to, and who are working on Google Cloud, no, they will not be working on the exhaustively and extensively on all these services. Most of these services in the real time people will be working on the job will be on BigQuery, Dataproc, cloud storage, data flow, then Cloud Composer, and sometimes data prep, and sometimes PubSub, and Data Studio and Looker. So these are the main places where mostly the data engineering, 80% of data engineering world works in Google Cloud. Very rare, I mean, there will be cases, of cases, people working in other areas as well, big table like on something like Vertex AI. Maybe some situations might be there, but very less compared to these ones. Which I just spoke about. BigQuery, SQLs, also Cloud SQL also is very important. Yeah, so that is about how we will be looking, and how we prioritize, and how we are going about understanding these services in the course of time. So this is about the BigQuery. As I mentioned, it is a fully managed petabyte scale, low cost analytics data warehouse. And I would like to go through this. We will go through this in depth in the future sessions, but that's what is the BigQuery is all about. The basic uses are used for machine learning, analyzing data across clouds. If you want to, if the data is dispersed across different clouds, you don't have to bring that data into Google Cloud. You can, using the BigQuery interface, you can still go leave the data in respective clouds, and you can still query that data. And you can have data across different projects, so your data need not be in your project, you have data in another project, and you want BigQuery to query the data. Yes, you can do that as well. You can materialize the views. That means that you will want to constrain your data output. You want to see, you see through a window. Do not want to expose all the columns and all the amount of data. You can still do it. And yes, there are governance and security checks available on BigQuery. There are other things that we will discuss, how governance and the security is established on BigQuery. So this is basically the uses of this of the BigQuery. A typical pipeline would look like this for using BigQuery. You have source data coming, low stores into the cloud storage. As I mentioned, for any migration projects and anything, the go-to path is the cloud storage, and from there it goes to the data flow, which is basically a managed NoOps pipeline, and from there it goes to the BigQuery, which is used for analysis purpose. Second one is the data flow. It is basically a NoOps data processing pipeline, and here little coding is required, and we decode it using the Apache Beam interface. And the main use of it is that you don't have to spin up any servers, you don't need any operational, there is no operational overhead, no and this part good thing is that it automatically scales, it horizontally scales and vertically scales. So that is the beauty of this data flow. So that means that vertically scaling within the node, it can scale, it can increase the compute and the storage, and across it can increase the worker nodes. So it can increase the number of worker nodes, scale up and scale down. Capability is available in data flow. You can, if people are not well versed in coding Python or anything, they can also leverage SQL capability in data flow. This is a recent enhancement that Google Cloud has announced. So that is another part of it, of data flow. The remaining ones are templates, so you do not have to, write these pipelines from scratch. There are ready-made templates. You can just take those templates down, bring those templates and build on top of those templates to write whatever specific transformation is required for your case, for building your pipeline. And how does it look in a architectural diagram? So you see this cloud IoT, you have livestock feeds, political tweets, financial tweets going into cloud IoT, and from there your PubSub is bringing those data. And then on the other hand, you have historical data, which is sitting in some, maybe in your in-house data warehouse, or maybe some kind of a storage media, storage. And from there you can get the data, and you can get it from the PubSub, which is the live stream as well. So it's basically used for streaming and batch load as well. And then you can this will be processed using the data flow, and it will be stored into a BigQuery environment for further analysis. Comes the data proc, which is basically used for the Apache Hadoop kind of workloads. So if our team was already working on a Hadoop environment in an on-premise cluster, and want to bring their load onto the Google Cloud, or maybe in Google Cloud, if our team is inclined towards working on Hadoop, and our business decisions emphasize us to work on Hadoop environment, then this is the go-to environment, and this is the service that we should be looking into, which is the data proc environment. And basically it is used for the doing extract, transform, load kind of operations. And it is scales, you can do resizing, you can don't have to manage the clusters. You can attach preemptive clusters, so once the workload is completed, it goes down automatically. Then it integrates with other cloud services as well. That is the another importance. And in data proc, you can also do neural network and machine learning algorithms, because it also is attached with GPUs. So that is the advantage we have with data proc. So we being in Spark environment, you can write programs to your machine learning algorithms, you can do transformation, you can also do deep neural network algorithm, build neural network models as well. So all this in single environment. And how do we do this? So this is how it looks. You have an on-premise environment wherein you have this Hadoop cluster that has data, which has Spark jobs and notebooks. So these are the three things that you have when in a Hadoop environment. And you want to migrate this to the Google Cloud. And where do you what is the go-to environment? You put all those things in the cloud storage, and our data proc communicates with the cloud storage, and then processes does the processing part of it. So then there are two things actually when we talk about data proc worker nodes. You can actually utilize its own compute and storage capability. But the only very part is that, again, because these are worker nodes, there is every chance that these worker nodes will go down, and there is no fault tolerant mechanism. If your business case demands that, well, to me my data using faster access is more important than the availability of the data, then you can think about storing the data locally within the worker node. Let's say, for example, there are situations like there is too much of data, like tens, hundreds of GB of data, and you want to process that, and it is taking too lot of time. So there is one of those use cases wherein you want to bring it into the worker nodes, and then processes this data, which becomes much faster. And once the processing is done, you put the processes data either in cloud storage or in BigQuery, and then bring down the nodes, so which will again bring down your costs as well accordingly. The advantage of going that route is, you have, since your data is locally stored, your ETL transformations will become much faster. much faster than what it is because on the cloud storage. But even in the cloud storage, it is not very slow. It is not at all slow, because the reason is that it uses this. We will talk about this networking, how this networking is done in Google Cloud. I mean, there is a concept called as Jupyter network. So it uses something called as a Jupyter architecture, wherein wherein it the wherein it uses the what kind of fibers, the kind of bandwidth that it uses is too high that you don't even notice that there is a latency in this network bandwidth. So that is the situation, that is the design that Google Cloud network is built upon. And we will notice that even by keeping that hundreds of GBs of data in Google Cloud Storage, you can still bring that data into Dataproc clusters with lightning speed, and then can process this data very instantaneously. Once the data is processed in Dataproc, you will be obviously taking that data, load that data into a BigQuery again. So that means all our aggregated data always will be there on the BigQuery for further building up dashboards or anything of that sort. Then the data fusion, as I mentioned, data fusion is basically a single click code free environment, point in click. So no code required, unlike your other environments, that is Dataflow and Dataproc, where you would want some amount of coding is required there. Here it is more user friendly, and you want to develop as a POC, or if a person who is working on this is not well versed in either Python, SQL kind of an environment. Here is this environment, like somebody like a Power BI visualization tool. Somebody works on a visualization tool. You want to build a build a pipeline quickly, so he can it will be very useful for people for such of that person. But and in some other use cases will be, you want to build a POC and you want to do it very quick. If you go with a Dataproc or data flow, it will be it will take time. But to showcase a POC kind of to some customer, prospective customer, data fusion might be the useful tool for us in that case. And yeah, these are the use cases where you would want to build those. It's not mentioned here, but as I mentioned, those are the use cases we have. And it will also be used with can be also be used for lineage. It will also protect the lineage, how your data has moved. And it can be used with other proprietary tools, along with other proprietary tools in the market, open source in the market. All these things it can be integrated with all the other tools as well. That's the uh, usage of this data fusion. And where does it fit in the architecture? See, if you look at it, it is it goes along with your data processing unit, along with the data flow. So from the beginning, if you look at it, there is data process sources, batch data and stream data. Batch data is going into the cloud storage, while stream data is being pulled by your the PubSub service. Both of them is again eventually take consumed by Dataflow and Data Fusion respectively, and each of them is doing their ETL transformations, and the transformed data is again stored into a cloud SQL, just to be different. I mean, I didn't. It was not necessary every time goes to a BigQuery. You can also think about another database, which could be a transactional database. Which is, what is this cloud SQL? Cloud SQL is basically an OLTP kind of a database, basically for high read write and kind of an environment where transact lot of input output and updates are happening on your tables. Then cloud SQL is the go-to environment in Google Cloud. And here there is a database that is coming, and it is being inserted into this particular database called as a cloud SQL. So this is about it, how the data fusion looks like. And that's it. And we are done for this session now. And we will look into each of these sessions in the coming days, going in depth and basically dissecting each and every service, and understanding and doing some kind of a hands-on sessions as well on on these services, and how they integrate with other services, and see how we can build kind of a different use cases. So that's about it, guys. I think we had a very good lengthy session, so almost like more than an hour. Any questions now? Over to you.
Pawan, is this mandatory for migration part? Like it is mandatory to store in cloud storage for batch processing and streaming process. For both the cases, we need to use cloud storage.
No, no. As I say, this is not a mandatory step. It is a best practice, I would say, a best practice, because mm, what cloud storage does is like a data lake. So not in every situation it might fit that it will directly go into the go-to environment. Say for example, say mm, most of this is raw data you want to bring. The raw data we cannot directly take it into into a Google BigQuery, because the BigQuery is mostly used for analytical purpose. Well, you can still do what we call ELT kind of ELT kind of a transformation. So you extract, load into BigQuery, and then transform it. Yes, that is always, there is always a possibility. But then most of the situations, use cases are that it will be in a raw format, and then that raw format you would definitely would want to be transformed and then loaded into their respective sources, their respective databases, whether it could be BigQuery or something like a SQL kind of an environment. So it is not necessary. You can directly bring. Let's say there is you have a ready-made data. You have a refined data. You have already transformed the data. It is sitting in your on-premise environment. You can use an EL kind of to take a help of storage transfer service, or maybe if it is too large, you take the help of appliance, transfer appliance, take the data and then put it into your the respective uh, databases. So BigQuery, you can directly connect to your on-premise and then pull the data from there and load it into your BigQuery environment. That use case is also a possibility. There is always a possibility.
Like
So
it is
my answer
mandatory
is,
to build a data.
pardon me.
Like it is mandatory to build a data pipeline. Like from migration part. In migration part, we need to mandatory to build a data pipeline, whether it is data flow or data proc.
Data flow or data prog, if you want to do an ETL type of transformation, then it is required. If it is an EL type of transformation, it is not required. As I said, extract, load. You extract and load it into your BigQuery. That's it. Simple. So you have a
Okay. There
data
is no
warehouse, in-house data. Yeah.
in case
Say
of
what?
ELT, there is no point of constructing data pipelines, right?
In ELT, we require a data pipeline, right? So, for example, you have to extract, you have to load. Sorry, yeah, ET. Yes, you are right. In ELT kind of a transformation, you will extract, load, and transformation is done within the data warehouse. Yes, you are right. In that situation, a pipeline will be is basically created. You can still have to create it, but then the creation will be more around extracting and loading and into the BigQuery, and in the BigQuery it will be basically doing the transformation.
Okay, okay, got it.
But data flow and will not be required in that situation, is what I'm trying to emphasize.
Fine, fine. Thanks. And also, what is the core difference between Data Studio and Looker, Power?
Both are used for visualizations. No major, no difference. But Looker has some ML capabilities. That's what it is doing. So more than the Data Studio. Data Studio is more resembles our Tableau. It is more close to Tableau and Power BI.
Okay.
So if you have already worked on Tableau, then you will notice that look, this Data Studio is almost same. basically. It provides the same kind of interface, same kind of tools and features, components within it are similar.
Okay, thanks.
Yeah, no problem. Any other questions?
Yeah, okay. In a recent days, okay, Google Studio
Who is
or Google
who
Studio, and
is
yeah,
Rakesh? Okay,
Rakesh.
hi.
Yeah,
Yeah,
yeah. Google Studio and Looker, they may be merged. I think after I seen the Google
yeah,
documentation.
yes. They might they are inclined towards Looker mostly,
Yeah,
more
I
than
think
Data
yeah,
Studio. Yeah, they will be inclined. They are inclined towards Looker. Many organizations are using Looker. It has. They are also bringing in one of that podcast. I already was listening that they are bringing ML, artificial intelligence capabilities into Looker. So they are merging. So nowadays it is like this. You one tool is catering many things. In Looker you have ML AI capabilities. In database, the concept of our understanding about data, relational database and SQL and NoSQL databases are is also merging tools as we move forward. In BigQuery, they are coming up with NoSQL kind of a things, and in a SQL they are bringing NoSQL kind of a technologies. In
I
NoSQL, like
think
MongoDB, yeah, they are
I
thinking
think
about how do we can write relational tables, how we can do joins and kind of things.
yeah, I think already BigQuery is a no SQL. BigQuery
BigQuery,
is already a NoSQL database. I think column based
it is a
database. That
columnar
is
fashion. When we talk about SQL, the immediate thing that comes to our mind is it follows that relationally concept, transactional relational kind of a thing. So and when we talk about that, when we refer to that kind of an environment like a SQL server or that kind of an environment, BigQuery is not that type of a database because it is good for querying, but not good for what we say relations. Sorry, what we insert. And that is what it is. So if you want to have it is good for querying purpose. So that if you are referring to the relations, then SQL is the best. Input, output, and relations. Going through the normalizations and other things. If you want to extract data for aggregations and doing reporting purpose, BigQuery is good for it.
yeah. In course, how many databases covered?
In course, we will cover BigQuery, Cloud SQL, mostly on Cloud BigQuery and Cloud SQL. We will look into the big table as well, big table and yeah, the Firestore as well. Yeah, these are the
Yeah.
ones which
How
we will
many
cover.
days? How many days it is required for BigQuery?
BigQuery most will take like 4 days, I think. Yeah, mostly around 3 or 4 days we will require 3 to 4 days. If we are 1 hour session, if we look at it.
Okay, fine. A Looker, how many days takes it Looker?
Looker also will take similar time for one visualization tool, one analytical tool, one SQL tool, 4 days. So that way we will have to plan.
Yeah. How many components covered in course?
How many components?
Yeah,
So
like
as
BigQuery and
query, so ingestion we as I mentioned like data flow and
okay.
will data prog. And in this one we have BigQuery, Cloud SQL mostly. And reporting Looker is the one definitely covered, and we'll be covering SQL, this big table. So these are the
In
main
to-
tools. So if you took at extraction, load, PubSub, we will be covering PubSub. There will be yeah, that is for streaming input.
okay.
Storage, yes, cloud storage, definitely.
What are the skills required for the prerequisite skills for the course?
Skills required. So some basic knowledge of the data engineering and And yeah, little bit about understanding about the cloud. Somebody was talking about what this is. So this is some kind of a storage and minimum basic concepts. This is the skills that we require. Apart from that, yes, remaining is covered here. So, any other questions, guys? Okay, then, yeah, we are done. Then I think we can close the session. And I thank Visualpath for giving this opportunity to talk here. And thank all the students who were present. I hope it was useful. let's let's come in the deep dive later in the remaining part of this sessions. Thank you guys. Thank you so much. Yeah.